warahmatullahi wabarakatuh. To carry on with the general embryology lectures, I'm gonna discuss in this presentation the events that take place at the second week of development. I'm Dr. Dalia Saleh, Professor and Head of Anatomy Department at Mansour University. So what are the events that take place at the second week of development? First, we need to know a little bit about implantation of the blastocyst, then the formation of the decidua, and finally the formation of the bilaminar germ disc. Let me remind you first by the events that took place at the first week of development. 12 hours after fertilization, the fertilized egg remains as a single cell. If we enlarge this single cell stage here, this is the zygote made of 46 chromosomes and remains as a single cell. Then after 30 hours, it starts to divide and become two cells. We call it two-cell stage. Then these two cells divide again and form the four-cell stage. And by the end of the third day of development, we end up with 16 to 32 plastomeres. In this stage, we call it the morula. And put your mind that all of this division occurs within the zona pellucida, so the zona pellucida is still intact around those newly formed plastomeres. At the same time, the morula is swept towards the uterine cavity by the cilia of the uterine tube. So let's enlarge this area again and see that this is the morula made of ball of cells, about 32 plastomeres inside the zona pellucida, and these are the cilia of the uterine tube, and they move in one direction to move the morula towards the uterine cavity. By the time the blastocyst arrives to the uterus, it's formed of hundreds of cells arranged into two layers. The outer layer is called the trophoblastic layer, the flat cell layer here, and this aggregation of cells is called the inner cell mass, and still they lie within the zona pellucida. Now the blastocyst moves towards the uterine cavity and gets into contact with the endometrium and starts its implantation there. By the time the blastocyst reaches the uterine cavity, it frees itself from the surrounding zona pellucida, the act that we called it before the hatching of the blastocyst. This is the zona pellucida, and this is the weak point where there was sperm entry at this site, and the blastocyst here, or the blastula, frees itself from this crust of the zona pellucida. By the end of the sixth day of development, the blastocyst attaches itself to the endometrium, then implants inside it. If we enlarge it here, it looks like this, and in cut section, we take a cut section in it, we will see that it has outer layer called the trophoblast and aggregation of cells at one pole, it's called the inner cell mass. So let's talk a little bit about implantation. Implantation begins by the end of the first week of development. We need to know the normal implantation sites. First, it is inside the endometrium of the uterus, or the inner lining of the uterus, at the upper part of the posterior wall of the body near the fundus. It goes into these steps for implantation. First, we have adhesion of the blastula to the endometrium, and then implantation, and then formation of coagulation plug. First, the adhesion. Here you can see the endometrial lining of the uterus, and this is the blastula, this is the trophoblastic layer, and this is the inner cell mass, and this is the blastocyst cavity. So adhesion begins with the initial contact of the blastocyst to the endometrium. Imagine that the blastula is like a ball. It rolls on the surface of the endometrium and gradually slows in its motility till it stops completely. And the inner cell mass, because it is the heaviest point of the blastula will align with the surface of the endometrium, like this. Next, we have implantation. The syncytial trophoblast, which looks like finger-like projections here, produce lysis enzymes that digest the endometrial cells. And when they open a room for them, the blastula will migrate into the uterine epithelium. The process of implantation complete by about day 9 of pregnancy. Finally, the coagulation plug will form, and it is formed of a fibrin plug that fills the defect in the endometrium where the syncytial trophoblast open a gap here in order for the blastula to migrate inside the endometrium. So this defect will be closed by a fibrin plug. Later on, the endometrial cells will grow and repair this defect. What about the abnormal implantation? The abnormal implantation could occur inside the uterus, but not in the usual place like I mentioned before, in the upper segment of the uterus. In this case, if the implantation occurs at the lower segment of the uterus, we call it the placenta previa. So placenta previa could be as follows: placenta previa lateralis, where the placenta lies at the lateral side of the internal os or the internal opening of the cervical canal. Another case called placenta previa marginalis, where the placenta covers the margin of the internal os of the cervical canal, and the severe case is called placenta previa centralis, where the placenta completely covers the internal os of the cervical canal. The other type of abnormality in the implantation, if the implantation takes place outside the uterus, in this case we call it ectopic pregnancy. The three common ectopic sites: first, the tubal pregnancy, which is commonest, then we have ovarian pregnancy, and the less common is the abdominal pregnancy. So this diagram summarizes the various possibilities of ectopic pregnancy. It could occur at the fallopian tube, at any part of it, at the isthmus, at the ampulla, at the distal end or the infundibular end of the fallopian tube, or even in the intramural part here. So these are the variations of the tubal pregnancy. It could also occur at the ovary, so in this case we call it ovarian pregnancy. It could occur at the abdominal cavity or the pelvic cavity. In this case we call it abdominal pregnancy. In this diagram we can see a face of an embryo that seems to be growing within the abdomen. So this could be tubal pregnancy after its rupture and the exposure of the gestational sac here, or it could be an abdominal pregnancy. In either case, this is an abnormal type of pregnancy or abnormal type of implantation, which is outside the uterine cavity. That's why we call it ectopic pregnancy. Now let's discuss the decidua. The decidua is the endometrium of the pregnant uterus. Is in the secretory phase. It's formed under the influence of progesterone. The function of the decidua is to support and interact with the gestation. It includes three parts: decidua pisalis, decidua capsularis, and decidua parietalis. What's meant by decidua reaction? It is the cellular and the vascular changes in the endometrium of the pregnant uterus at the time of implantation. For the endometrial glands, they will distend with secretion and glycogen. For the arteries of the endometrium, they will elongate and become spiral and tortuous. And for the stromal cells of the endometrium, they will be loaded with lipids and glycogen. And for the intercellular spaces between these cells, it will become wide. So again, what are the parts of the decidua? We said we have decidua pisalis, is the decidua that lies between the gestation and the myometrium. Decidua capsularis is the parts of the decidua that is covering the gestational sac, and decidua parietalis is the decidua lining the rest of the uterine cavity. What happens to these three parts of the decidua? The decidua physalis will hypertrophy and share in the formation of the maternal part of the placenta, while decidua capsularis and the parietalis, because of the growth of the embryo, they will oppose and come into contact with each other by the 12th week of development, and then they will degenerate because of the growth of the gestational sac. If we look at this diagram, we can see the different stages of development. Here, this is the morula stage. It's made of ball of cells contained within the zona pellucida, about 16 to 32 blastomeres. When they acquire a cavity, they form the blastula or blastocyst. Now these cells are arranged into two layers, outer trophoblast layer and the inner cell mass layer. Then the inner cell mass layer will differentiate into two layers to form the bilaminar disc or germ disc. The dorsal one is called epiblast and the ventral one is called hypoblast. And in the same time, two cavities appear inside the blastula. The dorsal one is called the amniotic cavity and the ventral one here is called the yolk sac cavity. So what about the amniotic cavity? This is the first cavity to appear within the inner cell mass. Its floor is made by the epiblast, and its roof and sides are formed by flat amnioplastic cells. It is first dorsal, and then after folding of the embryo, it gets bigger and bigger and it closes the embryo completely, like this. So this balloon is the amniotic cavity, and the embryo is contained within it. The second cavity to appear is the yolk sac cavity. It appears after the amniotic cavity. Its roof is made by the hypoblast, and its floor and sides are made by a membrane called the Husser's membrane. The newly formed cavity is now called the primary yolk sac cavity. After the appearance of the yolk sac cavity, another tissue appears. It's called the extraembryonic mesoderm. Extraembryonic means outside the embryonic disc. So these types of cells appear between the cytotrophoblast and the Husser's membrane. This is the cytotrophoblast and this is the Husser's membrane. It first surrounds the primary yolk sac and then will surround the amniotic cavity as well. Later on, cavities appear within this extraembryonic mesoderm. These cavities will coalesce together and form one large cavity. It is called the coelomic cavity. After the appearance of the coelomic cavity, the extraembryonic mesoderm will be splitted into two layers. Outer layer is called the somatopleurotic layer. It will line the cytotrophoblast, and inner layer that will cover the yolk sac, it is called the splanchnopleurotic layer. And now the primary yolk sac with its covering of the splanchnopleurotic layer is called the secondary yolk sac. With further development, the extraembryonic coelom grows and expands. There will be a mass of mesoderm called the connecting stalk suspends the caudal end of the embryo to the somatopleurotic mesoderm, which lines the cytotrophoblast. And this connecting stalk will be the base for building or formation of the umbilical cord that will hold the embryo to the placenta. So to summarize the events that take place at the second week of development, we call it week of twos. The trophoblast will differentiate into two layers, outer syncytial trophoblast and inner cytotrophoblast. The inner cell mass will differentiate into two layers, epiblast and hypoblast. Two cavities appear. The dorsal one is called the amniotic cavity, and the ventral one is called the yolk sac cavity. Also, there are two stages of development of the yolk sac, the primary and the secondary yolk sacs. And finally, we have two layers of extraembryonic mesoderm, the somatoploric layer and the splanchnoploric layer. This is the end of my presentation. Thanks for listening. And if you like it, please do not forget to subscribe, like, and share.